Calculate the following limits using limit laws. The limit as x approaches 1 of x squared minus 2x plus 3, and the limit as x approaches 0 of the square root of x squared plus 4 divided by x plus 1. For these limits, we'll need to use our two common limits, the limit as x approaches a of c equals c, and the limit as x approaches a of x equals a, along with the limit laws. The general idea is to break the limits up into some combination of just these two common limits, which we can evaluate easily, and then compute the limit from there. Starting with the limit as x approaches 1 of x squared minus 2x plus 3, we can break this up at the subtraction and addition using our first two limit laws to get that the limit as x approaches 1 of x squared minus 2x plus 3 equals the limit as x approaches 1 of x squared minus the limit as x approaches 1 of 2x plus the limit as x approaches 1 of 3. Then, since the limit of a power is the power of the limit, we can rewrite the limit as x approaches 1 of x squared as the limit as x approaches 1 of x all squared. We can also factor the 2 out of the limit as x approaches 1 of 2x. This gets us to the limit as x approaches 1 of x squared minus 2 times the limit as x approaches 1 of x plus the limit as x approaches 1 of 3, which is a combination of just our two simplest limits. The limit as x approaches 1 of x is just 1, and the limit of any constant is just that constant. So we can replace each limit as x approaches 1 of x with 1, and the limit as x approaches 1 of 3 with 3, to get that the limit as x approaches 1 of x squared minus 2x plus 3 is equal to 1 squared minus 2 times 1 plus 3, which equals 1 minus 2 plus 3, which equals 2. We'll take the same approach with the limit as x approaches 0 of the square root of x squared plus 4 over x plus 1. Using limit laws, we can rewrite this limit as the limit as x approaches 0 of the square root of x squared plus 4 divided by the limit as x approaches 0 of x plus 1, which equals the square root of the limit as x approaches 0 of x squared plus 4 divided by the limit as x approaches 0 of x plus the limit as x approaches 0 of 1, which equals the square root of the limit as x approaches 0 of x squared plus the limit as x approaches 0 of 4 divided by the limit as x approaches 0 of x plus the limit as x approaches 0 of 1, which equals the square root of the limit as x approaches 0 of x, quantity squared, plus the limit as x approaches 0 of 4 divided by the limit as x approaches 0 of x plus the limit as x approaches 0 of 1. Notice that since a square root is the same as raising to the 1/2 power, we were able to push the limit inside the square root just like we can with the power of 2. Basically, we have applied the limit to each individual x and constant in the original expressions. Now, just like the last example, we can evaluate the individual simple limits. The limit as x approaches 0 of x is just 0, and the limit of each of the constants is just that same constant again. So the limit as x approaches 0 of the square root of x squared plus 4 over x plus 1 is equal to the square root of 0 squared plus 4 divided by 0 plus 1, which equals the square root of 4 over 1, so 2 over 1, which equals 2. Notice that the answers we found in this example are exactly what we would have gotten if we had just plugged in the value of x into the function. For the first limit, the limit as x approaches 1 of x squared minus 2x plus 3. If we just replace x with 1, we get that the limit as x approaches 1 of x squared minus 2x plus 3 is equal to 1 squared minus 2 times 1 plus 3, which equals 1 minus 2 plus 3, which equals 2. And for the second limit, the limit as x approaches 0 of the square root of x squared plus 4 over x plus 1, replacing x with 0 gets us immediately to the limit as x approaches 0 of the square root of x squared plus 4 over x plus 1 equals the square root of 0 squared plus 4 over 0 plus 1 equals the square root of 4 over 1 equals 2 over 1 equals 2. This gives us a very important shortcut for evaluating limits. When evaluating the limit as x approaches a of f of x for a nice function, if plugging in x equals a results in f of a equals some number, then that number is the limit. What do I mean by nice function? Well, I can't fully define it yet. We need to talk about something called continuity first. But all of the normal functions you know and love, polynomial functions, rational functions, exponential functions, logarithmic functions, trigonometric functions, etc., behave this way. In short, if you can plug the number that x is approaching into the function and it works, meaning you get a defined answer, then you've just found the limit. Example, calculate the limit as x approaches 0 of 5x cubed minus 2x squared plus 3 divided by 2x plus 4. My first step for evaluating any limit is to try plugging the value of x in. If that value of x is in the domain of the function, recall that the domain is the set of all possible inputs to the function, so all the x values for which the function is defined. Then the answer I get will be the limit. The limit as x approaches 0 of 5x cubed minus 2x squared plus 3 over 2x plus 4 equals 5 times 0 cubed minus 2 times 0 squared plus 3 all over 2 times 0 plus 4, which equals 0 minus 0 plus 3 divided by 0 plus 4, which equals 3/4. Since I got a number, 3/4, I don't have to do anything more complicated. Technically, I'm using various limit laws to evaluate this limit, but the end result is the same as just plugging the number in.